So what we're going to be doing, guys, is we're going to use the PTW one-line diagram that we developed last week. We put cables in it. We put dummy loads in it. You guys are supposed to go modify them, add the right loads. And then after that, what we're going to do today is we're going to grab overcurrent protection devices and size these overcurrent protection devices. So here's what I want to do, guys. I want to start by, can you guys see the top here? Let's just go sit. Everybody can see where, if you can zoom into this area, you have the same one-line diagram. Can you guys see this stuff here? If you hover over, it says new low voltage breaker. Don't click on it yet. Here's a new fuse. These are new motor overload, and this is motor circuit protector. We have our special devices. At this point, this tab over here is all what you need for your overcurrent protection device. Now, Spencer, for this particular project, all what you need is just the first one. Can you guys see it? It says new low voltage breaker. That's the only type of breaker that we're going to be using. The only type. We're not using fuses. You can use relays. You can use high voltage. Look at this one. This is a high voltage breaker. You can do coordination between you and 13.8 and 138 kVA and all this stuff. The only thing we need to do, guys, for this project, make it simple. The only thing we need to do is use a low voltage breaker. Everybody can see it? So now do me a favor. Grab these two, the top. Can you guys see that? Grab them together and move them up so you can have a little neck here. Can you guys see that? So you can have a little room here. What we're going to do, can you see where I highlighted that little room? Move it up a little bit. Move your cable up. Okay, make sure you have enough room. Can you guys see, if you put your cables here, just move your cable and utility all the way up, and we're going to go size the overcurrent protection device for the system, the main. Everybody has room? You guys have room? Ben, are you?
It's opening up.
Is it opening? Okay. Do you see the riser? Or do you want me to get it for you?
I'm opening it up right now.
Okay. Because we've just started.
Okay, sweet.
Okay, if for the rest of you, I'll be with you in a second. Can you guys click on the low voltage switch now, a low voltage circuit breaker? Now you're holding a low voltage circuit breaker in your hand. All what you have to do is just make it touch that line, and click. Now you have just inserted a circuit breaker into the system. Everybody can see that? Now double click on the name, and what do you think we're going to name this circuit breaker? Start with CB, circuit breaker, dash, CB, we said circuit breaker, and then we're going to call it, it's protecting the switch gear, so we're going to call it, did we name the switch gear? How did we? Low voltage, low voltage. And we're going to call it SG. So when we are looking at this circuit breaker in the coordination, guys, isn't that what we named the switch gear? Yeah, we named the switch gear SG. So I call it circuit breaker SG. I give it CB for circuit breaker, SG to indicate that's protecting the switch gear. Remember how we named all the cables? Look at this. We named it C cable SG, the cable that's feeding the utility. We named the bus here. If you guys remember, we named the bus SG right in here to indicate that this is my switch gear bus. Okay? That's as easy as it gets when you drop a circuit breaker in your system. Now do me a favor. We're not going to drop a circuit breaker everywhere. I want you to drop a couple of circuit breakers so we can coordinate them. And if you just follow with me, that's easy. Everybody drop that one, right? Everybody drop that one. Let's go to the chiller. Can you guys see it? So we dropped the first one. Can you guys go zoom into the chiller that we designed the chiller? Can you grab the chiller and the cable like I did and move it down? Create a neck. I call it create a neck for it so we can stick a circuit breaker there. Just move it down a little bit. Are you guys with me? See what I'm doing? I'm just dragging him down a little bit so I can stick a circuit breaker there. On the chiller. Everybody, you guys went to the chiller? Dragged it down a little bit. Okay, so the same thing, DJ, I'm going to go click on a low voltage circuit breaker. Now I'm holding a low voltage circuit breaker in my hand. And what do you think I'm going to do? I'm going to go just make it touch the line, and off you go with a circuit breaker for the chiller. And what do I need to do with the name, Mr. Bab? Double click on it. The name, the convention that we're going to use is CB for circuit breaker dash. It's chiller, right? So I'm going to call it chiller. So CB chiller, so this will indicate that this is the circuit breaker that's feeding the chiller. Everybody's okay with that? Piece of cake? So I installed 2 circuit breakers, guys, one for the chiller and one for the main. Okay? We did one for the chiller and one for the main. Everybody did the chiller and the main? We're good? Okay. And named them. The naming is very important when we start doing analysis, guys. It drives you nuts if you don't name them. If you don't name them. I'm going to go, guys, to the lighting panel. Remember we said L, where's my lighting load? Right here. Can you guys see where the one that you named the lighting panel? Everybody can zoom into L load, B, LP. Can you guys see the lighting panel? We call it B-LP. That's the bus for lighting panel. And the load for the lighting panel. Everybody zooming in that? If you guys have a mouse, it becomes really handy. So do the same thing. Drag it, highlight it, drag, hover over them, and drag them down. Create a neck for the branch. Why do you think I'm doing that? Because I want to stick a circuit breaker there. Can you guys do that for me? Create a neck, Mr. Bab, for this. Basically by highlighting them and hovering over them. When you see that little cross thing, you can move them up. Look at that. I don't want you to move them up. We can move them down. The reason why I did that one, guys, to create a room to stick a circuit breaker there. Yes, sir.
Are we going to put a circuit breaker in a lot of things?
You're gonna not everything. Just you can if you want to. You can, yeah. You can start doing the circuit breaker in all of them. Yeah. Eventually, if we're doing a real project, you're gonna do circuit breakers in every single one of them. No we're not gonna use fuses if that's what your question is.
No. I was just going to say, I think after last time, everybody knows how to drop everything in. Tell us all only to one circuit breaker.
Okay. Okay, so that's I need to put data on him though. So grab a circuit breaker, guys, and stick it right in there. Okay, so move faster. What you're saying is, Chad, you're repeating yourself.
I'm trying to slow you.
Okay.
We just know we're going to drop it in. We're
Okay.
going to CBO.
All right, let's go see. Let's name it then. CB dash lighting panel LP. CPLP lighting panel. Perfect. So you guys are good with that. So I dropped one circuit breaker for the LP. All right, so that's another one. The other one I want you guys to drop for, I'm going to pick certain loads here to drop for mechanical panel. I'm going to take, can you guys go to mechanical, which one has the chillers? The mechanical panel number 2. Can you guys expand the go to mechanical panel number 2. You can expand it a little bit. And I'm going to go put a circuit breaker for mechanical panel number 2, drag it down a little bit. Mechanical panel number 2. Drag it and drop it, double click on it, name it CB-MP-1. So that's a circuit breaker for mechanical panel number 2. I'm sorry, thank you, MP2. So I threw a circuit breaker for mechanical panel MP2. Okay, so I have a lighting panel, the mechanical panel 2, I have the chiller. Eventually, guys, you have to put circuit breakers on all of them. But I want to do the coordination just to show you in a few of them. Optional to do all of them. Must do what I'm showing right now. I want to do the receptacle panel. Can you guys see the receptacle panel here? Everybody can zoom in the receptacle panel with its transformer. Do me a favor. Drag the whole thing. Grab the receptacle load. Drag it down. And again, grab the circuit breaker. Drop it. Double click on it. It's going to be CB dash. Now this is circuit breaker is going to be feeding the transformer, guys. Can you guys see that? CB XF-1. Just name it CB XF-1. What did we? And just to make it clearer, even RP. So here's what I did, guys. I named the circuit breaker ahead of the transformer as an XF1-RP. So when I'm looking at this circuit breaker in the coordination, I know this is the circuit breaker ahead of the transformer that's ahead of the receptacle panel. Very easy. If you name them, guys, if you don't give them a unique name that's you understand, your coordination will be very hard to follow. Okay? Do me a favor, grab everything else up here, and I'm going to go down, and I need a circuit breaker for the panel. See what I did? I just make a neck. I call it making a neck for that panel. Expand this one. The reason why I'm going to have another circuit breaker, guys, for the receptacle panel, Spencer, because I'm going through a transformer, right? Every time you go through a transformer, you need an overcurrent protection device to protect the panel at the different voltage level. at the different voltage level. So Chanel, since you are a smart aleck today, grab one of these, buddy, and go put it right in here, okay? Right on the spot, double click on it, and we're gonna call it CB RP, right? CPRP. So that will be, when I look at this one, I know this circuit breaker is the circuit breaker that protecting the panel, the receptacle panel, ahead of the transformer, after the transformer. Did you guys see what I did in the transformer branch? I have two circuit breakers, one to feed the transformer and one out of the transformer into the panel. And that's what we do in real life. In Revit, you should have installed the panel, that receptacle panel is going to have a main circuit breaker panel. You have to, because you have two different levels. What? I'm recording, Mr. Bell. I'm recording, Mr. Bell. I'm recording, Mr. Bell. That's right. Speaking of which, I want to go get my email off, Mr. Bell. Thank you. No, I don't want. Okay. Any question, guys, about these? Any question? Okay, so that's, I have lighting panel, mechanical panel, receptacle panel, and a chiller, The other one I would like to do is, do you guys see the bus duct with the transformer? I really like to do that one. So I'm going to grab, can you guys see that? The bus duct with the transformer, the 2/8 bus duct, drag it, and guess what I'm going to do? I'm going to go insert a circuit breaker, the same thing, double click on it. I'm going to call it CB. That's the bus duct that feed the 2/8 transformer. And I'm going to call it, what was the transformer? It's XF2. XF2 dash, what did I name that bus? BD208. BD208. Okay, so I inserted the circuit breaker ahead of the 208 bus. And the same token, Spencer, my friend, the same token, I'm going to go to the panel here, and I'm going to go insert, can you guys, the bus duct, right at the bus duct. Here's my bus, and insert another, yeah, just right here. Can you guys see that? Insert it. And what do you guys think this is going to be? CB for circuit breaker and BD208. So this is the circuit breaker that's protecting the 208 bus duct. Okay, did you guys put these? Name them, very easy, straightforward. Now we're going to go do the coordination. We named these. How many did we do? We do lighting panel, receptacle panel, chiller. We did the bus, and we did the mechanical panel, 5 of them. And the switch gear.
How can I move just the bus without doing anything else?
You can highlight the bus. You can highlight like here.
We did 8 of them, Chad. Yeah. 8 different circuit breakers.
Okay.
For the chiller and panel 2.
All right. So eventually, guys, you can do all the circuit breaker the same way. What I request from you guys is the coordination for these curves that I showed. That's all. You can go ahead and do the whole coordination. I'll show you. You're going to see it's a piece of cake. Okay? Everybody's there? Everybody cool with that? So now all what we did is we just dropped the graphic, a model. We dropped the graphic, a model. We didn't do anything. We just dropped the graphic. Now, Holly, if I ask you, do you think this is the bus duct 480? Do you think this needs a circuit breaker here? Yes. Am I going to put it now? No. Because I want you guys to concentrate on other things. But eventually, if you want to do a good job on this project, you should go there and put a circuit breaker for each one of them, which is very easy. Okay? But please, if you just follow up with me a little bit, because I want to do the coordination for these curves, then I'll let you go with everything else. Are we good, DJ? Good? Okay. Now there are generators here, guys. We can set the circuit breaker for the generators the same way and coordinate with generators. We're not going to do it, but you can go ahead and do it exactly like the utility, like I'm going to be doing. Okay. Now I want you guys to go zoom into the switchgear circuit breaker. Zoom right into the switchgear circuit breaker. Everybody's there? The CBSG, the circuit breaker switchgear. I'm going to go double click on it. When you double click on it, guys, it opens. I want you to look at what it opens. It opens, make sure you're looking at CB. Can you guys see that? CBSG, right at the top. Open the component editor. Component editor. Everybody's there? Now this is where you become a good power system analysis engineer. You need to go pick up the right circuit breaker. You guys don't know which circuit breakers are right. Here's the assumption that we're going to do. We're gonna use collar hammer because your friend Chad is familiar with their circuit breakers. That's the only reason we're going to do it. And I'm going to go, guys, to the switch gear. Everybody is looking at the same window I'm looking at. Okay, I want you guys to hit the library. Remember how we loaded the library for the cables? Every single component in this software has a library database. So can you guys click the library? If your library is screwed up down at the bottom like mine is used at the bottom here, can you expand it? Hit expand and off you go, you expand it. Are you looking at the library that I'm looking at, everyone? I want to bring to your attention a few things, guys. Do you guys see right in the left-hand side? This is all your low-voltage circuit breakers. You can have fuses, relays, high-voltage special devices. Today, we're not going to mess except with the low-voltage circuit breakers. If you're working for Michelle Cooley Erickson or anyone engineering firm or contractor, you're going to do coordination, make sure you come right here and look at all that overcurrent protection devices, from relays to disconnects to special high voltage, medium voltage circuit breakers, all the way to special devices that you can put there. To Spencer, 99% of the time, I would not 95, 90% of the project up to 4,000 amp circuit breaker you can get away with low voltage breakers. Everything that you need is under low voltage breakers, 90% of the time. If you're doing medium voltage and high voltage, then you're going to go into the medium voltage. Can you guys see the high voltage stuff down here? Okay, we're not going to go there today, so I just want you always to look at the low voltage breakers. Low voltage breakers, there's a few types, guys. There's static. These are the electronic ones. If you click on them, it loads everything statics that God created in the US, sold in the US, a library for every circuit breaker. If you hit thermomagnetic, everybody knows the difference between static, it's electronic, and then power circuit breakers. And you can hit power circuit breakers. You can have statics and power circuit breakers, and you can use thermomagnetic. The circuit breaker that we're going to use, guys, is under static trip. It's an electronic circuit breaker. Okay, everybody's okay with that? Make sure you clicked on static. I want you guys to go down all the way to collar hammer, all the way to collar hammer. Everybody can see. Okay, all the way to collar hammer. Everybody can see where collar hammer starts. The circuit breakers. That's what the circuit breakers we're going to use is collar hammer. Now I want you to use a circuit breaker, and you probably wouldn't know that. I want you guys to expand this a little bit. You can expand them to see what you're looking at. Those of you who were with us last week, we talked about Magnum DS circuit breaker. Magnum DS circuit breaker. Now, Spencer, the main circuit breaker is going to be a 4,000 amp switch gear, right? So I'm looking at a 4,000 amp switch gear, 480 or 600 volt, right? So let's go look at the one that I want you guys to pick right away. Is I need one that can give me all the way to, look at this one, DS RMS 510 6. Can you guys see that? I want you to, actually the one underneath it, because I need to do things. Can you guys pick the one that says DS RMS 510 610 810 910 LSI? Do you guys remember what LSI? Long time, short time, instantaneous. Remember how when we did last week, when we were calculating the long time pickup, short time pickup, and instantaneous? That's exactly what LSI is.
I don't see a Magnum 510.
It's DS. Can you see that?
Yeah, no, I have Magnum DS, RMS, they say 520, 220.
See these one? Can you see 510, 610? You see them? Are you with collar hammer?
Color hammer under the Magnum DS.
Just go DS.
Oh, I thought you said Magnum DS.
Yeah, go DS. You went all the way to the Magnum ones. Okay. You know what? I think you're right. Well, let's go to, because the one that I did is Magnum yesterday. Let's follow that one, the Magnum DS. Let's go to the Magnum DS. That's a good idea. Can you guys go to collar hammer Magnum DS? That's, I'm familiar with that. It's actually, here's the voltage. What's the voltage in that baby? Magnum DS. Collar hammer Magnum DS. Let's look at the voltage. Voltage, as long as you have more than 480, that's good enough. Let me see what my best voltage would be for Magnum DS. 400 amp, long time, short time, instantaneous. Magnum DS 520. For all practical reasons, guys, we can pick any one that we want, at least for this time. So let's see, Magnum DS. I'm going to look at the one IEC. We don't want IEC, we want ANSI. Magnum DS 220. Let me pick one for you and call it, and we do the coordination in it. Magnum DS 520. Magnum DS RMS 520, 4000 amp. Can you guys pick that one? I want the 600 volt. Can you guys see the Magnum DS RMS 520 and it hit 4000 amp frame? Everybody can pick one. Could you please pick that one for me?
There's two of them, doesn't matter.
2500 amp and 3200 to 4000.
The 3200 to 4000 amp.
Can apply or what?
Okay, are you guys, everybody got that one? Double click on it or apply. Double click on it. Now you loaded it. X the library. Exit. Now you're out of the library. Okay, now you're looking. Can you guys look at the one that we picked? It says 480 MS 480 4000. You X the corner here.
Does it say MDS 840? I can't.
Yeah.
MDS 480. Yep. Okay, now I want you guys to go change. Can you say the sensor? Remember what we did the sensor last week? Grab the sensor 4000. I need a 4000 amp sensor. And the plug, I want the plug to be 4000. Okay? So only thing you need to do, make sure it's 4000, 4000. Can you guys see the long time pickup? I want the long time pickup to go all the way to 1. This means I'm taking full advantage of the... So change this one to 1 and change 4000, 4000, you're good to go. Okay? Everybody's okay with that? 4000, 4000 done. Cool? All right, exit. Set. Now this circuit breaker is loaded with info. I picked this one 4000 amp, guys, because it is a 4000 amp. Now the one, let's go to the chiller. What was the size of the chiller that you have? 1200 amp? Anybody remember the size of their chiller? Let's go to the size of the chiller. Can you go to the chiller, guys? Everybody's the chiller? Right at the chiller. Double click on the chiller. What size did you guys come up with the chiller? Anybody has the size? 525 kVA. 525 divided by 480 divided by 1.73 equal times 123 equal times 1.75 equal, and you can get away with 1000. So let's go to the library again. Click on the library. It takes you back to the same circuit breaker. The problem with the circuit breaker that if I pick the same one, guys, it doesn't go as low as 1000. So I'm going to go pick the same one that can get me a little bit lower though. Long time, short time, instantaneous. I'm going to grab long time, short. Stay with the 50. I think a frame of. I don't want the. I want stay with the 600 amp, long time, short time, instantaneous. Let's look at this one. This is long time, short time, instantaneous, 1600 amp frame. 1600 amp frame. Look at the one underneath it. I need the plugs, guys, smaller plugs. Can you pick up the one that says Magnum DS RMS 520, long time, short time, instantaneous, 1600 amp frame, 200 to 1250 plug. So I can plug them at 200 all the way to 250, meaning I can use that same circuit breaker for all my circuit breakers in the feeder size. Okay, everybody got that one? Jim? Okay, double click on it. Everybody got it? 16. Grab the 1600 frame, 200. If you made a mistake, by the way, you can go back and grab another one. I mean, it's not like you're doomed. Okay?
So these settings and all this stuff that we're doing, it's just something that we should know on into the contract.
You'll see in a second. Just let's drop them first. Everybody got that one?
Yeah.
Okay, you got them? Did you guys get them?
Yeah.
Okay, exit out of it. Now you're looking at this circuit breaker. It's 1600 frame. I want you guys to go down to the one just underneath it, the 85K. Can you go to the 85K because our switch gear is 85K? Just click here and it gives you different interrupting rating. I want to pick up the 85 because my switch gear was 85. Did you guys pick up the 85 at the end? Okay, now what do you think we're gonna size this baby at? We said it's gonna be 1,000, right? Plug it, sense it at 1,000, and also plug it at 1,000. I put my sensor and plug it at 1,000. Now this 1600 frame have just by the plug in the sensor changed it to 1,000 amp. Okay, what do you guys think I'm going to do the setting number 1? Always put the long time pickup at number 1. You're done. You have just dropped a 1,000 amp circuit breaker. A 1,000 amp circuit breaker. Long time pickup. The first one.
I got an issue, Chad.
What's
I think the same one as you.
Yep.
So did James, but I can't change my sensor. Yeah, I can't change the
Did you guys click? Did you pick the one that says at the end 85K?
Yeah, and he picked the same one.
Read what you have. Read it. It says 480 volt.
Yep,
MDS 816.
yep,
1600 85K.
yep.
Okay, and then the plug. Click on the plug.
It says 16 and the sensor says 16. I can't change either of them. But James is the exact same one. He can change.
That's interesting.
Yeah.
Okay. Let me see it. Look at it.
That's the right one.
Oh, you're using the 816. Yes. 816.
Well, the one thing didn't have it just for me.
Okay. All right. Did you guys get them? Get that one? Okay. Now we're going to make it very easy. We're done with loading that. We're going to use two types of circuit breakers in a switch gear, guys. The 4,000 amp and this type. So close it. Now do me a favor. Do me a favor, gentlemen. Right click on the chiller. Remember, that was the chiller. Right click on it. Do you see where it says copy data? You guys see where it says copy data? I want you to go to the chiller one, not the main. Spencer, my friend, you're going to go to the chiller, the circuit breaker for the chiller. Right click on it and copy data. Now, what I'm going to do, guys, I'm going to copy the same data for all the circuit breakers in the switch gear, the feeders of the switch gear. So let's start with this one. This might be tricky a little bit. Don't copy on the main though. So hold the shift and grab the circuit breaker number, this one and this one. Don't pick the main, please. Don't pick the main. So I grab these two, all these circuit breakers. What else? That's it. All the other circuit breakers that's coming from the switch gear only, not the one after the transformer. Did you guys pick him up? Okay, right click, hover over one and right click. Are they still picked up? And do you see where it says paste data? Yeah, they're supposed to be blue. Can you guys now paste the data? Drop the data. Now guess what you have done, Jim? You have loaded the same circuit breaker for all of them.
Did you do the lighting panel on this thing?
Not the lighting panel. I did not do the lighting. I did not do anything on the secondary side of a transformer. Okay, the only
Either side of the lighting panel,
The only, yeah, the feeder side. The only ones that I guess I did are these. These should be now loaded. All these.
You hit shift, it selects one, mine
Or
doesn't.
control, I will
I
control.
was gonna say mine don't save the rule.
You control.
Okay.
Okay, can you guys go to the lighting panel circuit breaker? Double click on it.
You hit paint and then.
Double click on it.
Hit paste data.
Yep. Okay, and go to settings. Do you see a 1000 amp? One more time. Okay, so if you paste them right, here's what you need to do. Go check. Let's go to the lighting panel circuit breaker. Everybody's there? Lighting panel circuit breaker. Double click on it. You should come up with this. Go down just one step to the settings. Do you see 1000?
For the sensor?
Anyone, as a matter of fact, anyone, but I'm going to check. Double click on host.
1,000 for the sensor?
Yes. I just want to make sure that I copied the data. The data is there. Okay, let's go one more time. Double click on it. Open the lighting panel circuit breaker. Hit the setting. Do you see 1000 for all of them? 1000. Okay, so means your data has been copied. Your data has been copied, right? That's good. That's what we're going to do. Okay, are you guys in the lighting panel? Everybody's in the lighting panel. Circuit breaker, looking at what I'm looking at right now. So let me give you a good news. Your lighting panel is going to be close to 225 or 250. The only option that I have is 250. So I'm going to go pick up, change it to 250. That's the circuit breaker now. The 1600 amp frame in a click of a button turn into a 25 amp circuit breaker. 250. 25 tens. 250. That's the lighting panel for the circuit circuit breaker for lighting panel.
It's not allowing me to make another disconnect. I need a circuit breaker.
Hold yours a second. Everybody change this one, guys. Everybody can see that this is 250, and my setting is 1, right? At the lighting panel. Okay? At the lighting panel. Everybody's there? All right, close it. Now we did set this circuit breaker. Let me check my friend. You can do the same thing, guys. Go while I help my friend. Go to the mechanical panel. Can you guys see the mechanical panel circuit breaker? Double click on it. The mechanical panel, most likely, you're going to end up with an 800 amp. Mechanical panel. The one that we only did 2. We only did 2. So mechanical panel, can you guys go change it to 800? Sensor 800. Now, if your panel was 700, guys, you can pick up a 700 and you can set it up later. We don't have a 700. We have 6. We start with 800 and we adjust it with the setting. Okay, did you guys pick up the 800 for the mechanical panel? Close it. Let me check my friend. What did you want lighting panel at? Lighting panel 250. Okay. Yeah.
So it's under LP. I need to get it. So we're going to copy it or something.
Yeah. Copy the chiller. Circuit breaker from the chiller, slip on it. No, not that, no, that's, you didn't have to. Click on it. Copy data. Zoom out, we go with the circuit breakers. Hold control. When you start you're copying data. If you don't have a circuit breaker, you wouldn't copy it. You don't have a circuit breaker, copy it. So you where's your circuit breaker? You need to drop the circuit breaker. Okay, grab the circuit breaker. And attach it here. All right. Okay, guys, we did the circuit breakers. Almost there. The last thing I want you to do is, do you see these two circuit breakers on the secondary side of a transformer? Can you guys see the two circuit breakers? Let's go to the receptacle circuit breaker. Everybody's there? Receptacle circuit breaker. Okay? Receptacle circuit breaker. You okay, man? Double click on it. Double click on the receptacle circuit breaker. Receptacle panel circuit breaker. The one below the transformer. The receptacle panel circuit breaker. One more time.
I'm there.
You're there? Okay. Right here. That one. Everybody's there?
Yes,
No. Okay. Guys. Yes. Yeah. Guys, the receptacle panel on the secondary side of a transformer is not a static circuit breaker. It's a magnetic. Okay, yeah, we didn't copy it. Even if you copy it, you can change it. We did not. So are you guys looking at CB-RP? Everybody's looking at CPRP, okay? Go to the library, click on the library. It takes you guys to color hammer, right? All right. Instead of static circuit breakers, these most likely are molded case circuit breakers. So click on thermal. Everybody can click on the thermal. Can you guys see where thermal is? Grab a thermal circuit breaker for it. Okay, click on the thermal. Everybody clicked on the thermal. All right. So let's go and let's go all the way to color hammer. And I need really to grab. That was a receptacle panel. Receptacle panel 225 amp. Let's go grab, and that we can adjust it. I'm gonna go grab. You can, for all practical reasons, you can grab anyone that can give you that amp. Let's just go for one that I can adjust a little bit. So if you go, no, I don't want Challenger. I need circuit breaker, color hammer. Okay, are you guys with color hammer circuit breaker? Okay, let's go look at the voltage. I need a 480 volt circuit breaker. Make sure you look at. Okay, let's see if we grab. I'm going to grab one low end one that I can adjust. Okay, 3-phase 480 single pole 100.
You have the little voltage button, Chad, up top. It'll just line all your voltages up in order.
But I want by the
Scroll down to color hammer, so it's
Okay.
really easy based on what your list.
Okay. HL.
I'm telling you,
Okay.
quick, easy way to do it.
600. Let's grab, guys. I'm looking at the ranges 700 to 400 amp. That's good. That will cover almost all my panels. And I actually know, because we have we can pick another one. HKD 600, 100 all the way to 400. Can you guys grab that one? In reality, what would you do, guys? Which one would you grab? When you buy the switch gear, they'll tell you which type of circuit breaker they're using. They will tell you we're using HKD circuit breaker. You can come here and grab it. That's all.
We're looking for a 600 volt.
We're looking for a 600 volt circuit breaker, 100 amp to 400 amp. Okay? Did you guys get that one? Double click on it. Now it's loaded. If you come over here, these circuit breakers are kind of, look at the voltage that comes with it. I need to pick up, which voltage do you think I need to pick up? That was on which side? That was in the receptacle panel. So the voltage on it is which voltage? I can get away with 240 because it's 208 panel, right? So what was the size? Let me just see what the size of the amp panel. So let's go to, let's assume your panel guys what 225, receptacle panel 225. Can you guys see that? Go grab a 240 volt, 225, 100 kVA, because this system is 208. So that's 240 is good enough for 208, right? Everybody got that one? 225. My trip is 225 and my plug is good luck. These are non-adjustable circuit breakers. And my curve, look at the settings. Can you guys adjust the settings? Nothing. They're fixed. That's the difference between the thermomagnetic circuit breakers and a non-thermal. Okay?
Can we just copy the data to the next one?
Thank you. We're going to go copy the data from that boy. Copy data and go to the one to the bus duct 28. Right click on it and paste it. Paste the data on the circuit breaker that's going to the bus ducts. Okay, double click the bus duct though. Everybody guys copied that? Double click on that one. And let's go see the settings. The settings are not 225 for the busway. So let's go pick up a larger setting, guys. You might have to go to a different, this is as high as I can get in this circuit breaker. 400 amp. This is as high as you can get. Now, what size is your busway? 208. Okay, if it's close to 1,000, then you're going to go click out of it and go to the circuit breaker. Let's go grab a different circuit breaker. So go to the library, go library, and let's go grab one that can give us more amps, guys, than this. So more amps than this on the secondary side.
There's one that's 300 to 800 amps.
Okay, look at this one. Let's see this one, guys. Can you see that 700 to 1200 amp? That should be good. H&B collar hammer, 600 volt. That's more than what I need. That can give you 700 to 1200 amp. Did you guys see that? H&B collar hammer, H&B. I just want to capture up to 1,000 amp on this type. Did you guys grab it? Double click on it. Now, HNB. Now it's set for 240, guys. That's good. I'm going to go trip it at 800. Well, I need 1,000. If your bus is 1,000, so to go 1,000, go to 1,200. The 1,200 give you 1,000. Can you guys see that? I grabbed a 1,200 at 240, and then the trip, I grabbed the trip of 1,000 on it. So I have a 1,200 amp frame tripped at 1,000 amp.
I still can't find that one yet.
Okay, let's go back again. Circuit breaker, library. Camille, can you see it? It's right above the HQP-1 pole. HN. And B 700 to a 1,200. Got it? Okay, close that one. All right, now we're done with these curves. Close out of this. Now, guys, I have my curves, my circuit breaker set. If you made a mistake, you can go at any time and change the circuit breaker type. If you guys, when you do your size, you discover that the manufacturer have used a different type of circuit breaker, what do? You go there and pull the circuit breaker. Now we're going to go to coordination. I'm going to do one coordination, give you a 5 minutes break, guys. Do me a favor. Here's how we do coordination. Can you guys, everybody's following me? Even if you don't put data in your circuit breakers, please follow this step. Grab the main. I'm going to do coordination between my main, hit the main, hold the control key, pick the main, and make sure you pick the device, not the text. The device, not the text. Everybody, make sure you pick the device. The device should turn into blue. I pick the device, the main, and I'm going to go all the way to my chiller. Pick the chiller. Everybody picked up the chiller? Make sure you hold the control key when you do, so you can pick both of them. Hold the control key and pick the chiller, circuit breaker, and also the chiller. So you should select 3 things: main circuit breaker, chiller circuit breaker, and the chiller itself. Okay? Even if you didn't put data on it, just pick them up. You can populate them at any time. Okay? Do you guys have 3 things highlighted? All right, now look at this. Do you see where these curves at the end here? Everybody can see these curves? Go to TCC. Can you guys see that? Right in there. Go to CCC. Did you pick things? If you didn't pick things, you're not going to see them.
Nothing came up when I clicked it.
Now hold your horses. Everybody can see it though? Click on it. Give me 1 second. Click on it. Do you guys have a window open like this? Type chiller. Chiller. So this will be the coordination for my chiller. Type chiller and hit new. Type chiller, hit new. Here's your coordination curve. Hit OK if you see it. Everybody is looking at a curve that looks like this. Okay, hold your horses now. What do you have, Mohammed? Here's the curve coordination for this. Yeah. That's interesting. Oh, right here. Yeah, right here. See where it's sitting right here. You're right here. It just shifted to the other direction here and here. And Muhammad, it just shifted in the other direction. And call it chiller. Chiller. And no. And you're right with us. Oh, but you didn't put data on them. Did you put data on them?
Yeah, I did.
If you put data, it should populate. There's no data on them. Okay. One more time. Maybe I pick the here. Control. This one. Pick it up. And this one. Right? Here. Chiller. Oh, did you have a short circuit? Did you run a short circuit in your system? Run. Balance studies. You have to run the short circuits first for the system to. You did last time with us, right? Yeah. What the heck? I don't know. There are no components in the TCC. That's really interesting. TCC. Go to. Yeah. These are just the curves that you have here. Okay, you can hold your. I might have to call them. Everybody else was able to guys reach this one? All right. Let me just adjust the curve for you. You take a break and we'll get back. Look at this, guys. This is the curve that somebody will pay you money to play with these beautiful, nice looking curve. Expand this so you can see the whole thing. If you look at Spencer, look at the first click on device. Here's here's the device that you're picking. If you click on settings, here's the settings that you're picking for this device, the database, and the one-line diagram. Okay, so you can click on these and get different views for the curve. All right, I like to put it on settings. So can you guys see that they don't have room on the right-hand side? Can you guys see that you don't have room on the right-hand side? Let's go adjust this one. Do me a favor. Can you click on settings? Can you guys see where setting is? Settings, TCC settings. And can you do me a favor, add a 0 and a 0 on both the top, the minimum, and the minimum. Can you guys see? I added 1 0 here and 1 0 here.
Did you get to that?
And okay, one more. See how it shifted? It shifted it. One more time. To adjust the curves so you can see them, guys, they're all going to the right. I'm going to adjust the graph. Go settings, TCC. It gives you the current axis range. I'm going to add 1 more 0. Why don't you add 1 more 0, shift them. And also the time axis curves. Let's add another 0 for them and shift. Look how it's situated my curve right kind of in the middle of the graph. Okay? Everybody did that? Now, if you click on the curve, guys, the first one is the switch gear. Can you guys see that's the switch gear? The second one should be the chiller. Here's my chiller. And the third one is the chiller start curve. Can you guys see the chiller start curve? If you click on any one, it will show you the settings for it. Like, look at that. switch gear settings, you go to the chiller settings, you go to the chiller itself, that's the curve, that's 525 kVA chiller. You can adjust it from there. I want you guys to look, this chiller right now, can you guys see the overlap between this and the chiller curve? The overlap, every time the chiller will start right now, it will trip the circuit breaker the way it is. So that's what coordination is all about. Can you see that leg here? Look what I'm going to be. I'm going to drag that leg all the way and move it away from the start curve. It used to be, guys, right at the top of the start curve. If it's like this, every time you start your motor, can you guys see that two curves, the starting curve and the curve of the circuit breaker are overlapping? Everybody can see that? Now this is a mismatch. Every time you start your chiller, the circuit breaker will trip. Bad news. So what you need to do, click on it, expand it, move it up to the right, and all the way slightly up to here. Okay? Can you guys see that? Did you get that? The graphically, the chiller and chiller circuit breaker and the chiller are not touching each other? At least these two. Everybody's okay with this?
You don't want to touch each other, you just want to really close.
Yes. Now let's go to the main circuit breaker. Move it. Move the main circuit breaker, guys, a little bit up. Can you see how I'm moving my circuit breaker all the way as far as I can get it? My main circuit breaker. My main circuit breaker, move it as far as you can get. Oops. You might have to do it twice. Click on it physically. What you're doing, guys, is you're adjusting your circuit breaker. Are you guys looking at something similar to this? You have just did an overcurrent protection device coordination. Now,
So where do
Spence,
you want the main to be in?
move it as far as you can go to the right. As far as you can go to the right. As far as you can go to the right.
And up top.
Okay? Now, can you guys see that at the bottom, they are miscoordinating right here? Right at the bottom here? Here's what we do because switch gear. Click on the switch gear. Make sure the switch gear is dark. When you click on something, guys, it becomes black. Are you guys on the switch gear? Go to the settings. Hit the settings. Everybody's there? Okay. So what we do, guys, highlight the instantaneous. Highlight, click on inside the instantaneous. I want to disable the instantaneous. I'm going to disable in the main, on the main circuit breaker. I'm going to disable the instantaneous. And
Yeah, so where do we do the settings, which setting are we hitting? With that?
DJ, if you click on, whenever you click on a curve, it brings the settings for it. So let's go to the main. Make sure the main is black. Is your main black like mine? Okay. You
This is
can,
what I can argue.
oh, you can go to device, and you can go to settings, or you can go to data block or one line diagram. I want you to be on settings.
Is this something that we're gonna do in the field?
Yeah, if you work for engineering firms.
I mean, this seems a lot more in-depth than something that, I mean, you know what I'm saying? This is like a pretty serious deal right here, and I'm not.
Yeah. Did you?
My head, I imagine.
Okay.
I'm just sliding stuff around. I don't know what's going on.
Did you get the settings, guys? Everybody right at the settings? Highlight this. Did you highlight the instantaneous? And hit delete. I think it delete or remove. Where is the insert? Delete, no, delete segment. Can you guys see that at the bottom here, delete segment? See how it moves it up? It moves the curves up. And you can move your curve as high as you can get.
Just delete
Perfect.
My whole
You hear, sir?
thing.
Whole main. We can bring another main. Not a big deal. Did you guys highlight this?
On this program?
I don't know. Project. I can't remember when we do. Okay. Everybody, guys, I'll get you your curve. Everybody is looking at a curve similar to this? Almost. This is a full coordination between the main. Look at the main. Between the chiller overcome protection device and the chiller itself.
My chiller wanted to go.
You what?
The chiller is crossing and I can get it to move.
And did you try to drag it?
Mm-hmm.
Oh, you gotta drag your blue over past it. There you go.
You're doing that over?
Yep. Drag it to the other side. The other side to the right. There you go. Keep going. There you go. You're in. Perfect. Perfect. Okay. Are you guys looking at a curve similar to this? Do me a favor before you leave. Go to run, and run a TCC report. Can you guys see that? Run a TCC report. This is the report that you need to print for your project. Run the TCC report. It tells you, do you want to run it for the chiller? Yep, okay. And take the default, and it will, where do you want to save it? Just take the default, and now you ran a TCC report for this chiller. What's a TCC report? If you guys look at this, this is what you're going to be giving to the electrician in the field right here. Can you guys see that? You give it, so long time pickup 1, long time delay 24, short time pickup 10, short time delay 0.5. You give them to the electrician for which circuit breaker? This one, for the main. And that's the report that you give to your electrician. For the chiller, look at the chiller. Here's the report they're going to give to the electrician so they install it. Long time pickup 1, long time delay 7, short time pickup 6, short time delay 0.2, and instantaneous 6. These numbers report, we give them to the electrician go to the switchgear, and they physically, mechanically adjust the settings on the switchgear circuit breakers. Okay? Everybody ran a report like this? It's already saved, so don't worry about it. It's already saved. Yeah, exit, go to the X here and exit, and you go back to the, now you guys have done two things. You ran a coordination for the chiller, and you ran a report for it. You're done for this branch. Why don't you guys go take a 5 minutes break, and I will do 2 more branches with you, and you can do the others.
So when are we gonna?
How do you get back?
Okay?
How do you get back to one line?
Cross X. See the X here? Exit. Yes. I X out of everything. I don't want to X out of everything. There you go. Close.
Oh, yeah.
Industrial project. One line diagram. Okay. Let's give you 5 minutes, guys. I'm going to do one more coordination, and then we'll let you lose some help. Chanel, what was the issue, bud?
Oh, nothing, I just deleted my switchgear on my field.
Sorry. Record. All right, we're going to go pick up the main circuit breaker switch, the main switch gear circuit breaker, and the circuit breaker for the transformer that feed the panel, and the receptacle panel main. Can you guys see that? 1, 2, 3. And do me a favor, grab the transformer as long as you're on it. Did you guys grab the transformer? Click on the transformer. So we have 4 things. Did you guys have 4 things? 4 things. Oh, very hard. 4 things. Okay, everybody has 4 things. Let's go back. Every time you need to do a coordination, Camille, you grab them and you go to where? To the TCC. Click on it. Now we tell you, before you go there, what do you guys want to call this is? Call it receptacle panel, RP, just RP. We know it's RP. So this is the coordination for the RP, the receptacle panel. Everybody's okay? I'm going to call it new because it's new. And off you go and hit OK for this. And off you go, guys, with a curve that looks ugly like this, right? Does your curve look somewhere like this? Somewhere like this? Okay? Before you do anything, guys, I want to see where the main circuit breaker is disappearing because the scale, I want to readjust the scale for that one. Can you guys go to settings, TCC,
Oh, I got the chiller on there too. How did I do that?
because you double click on the chiller. When you select, did you have it selected? That's okay, we'll remove it.
Doesn't select it.
We will remove it. That's an easy fix. Okay, one more time, guys. Can you go to TCC settings, TCC settings? Can you add 2 zeros on the first current X range? 2 zeros here. And okay, see how shifted everything?
What if you had the 2 on the bottom?
That's okay. Shift the top too. Okay? It looks like this. Does yours look like this? One thing, Spencer, you're going to do, the switch gear, don't mess with it. Do you see, guys, that black one? That's already coordinated. Don't mess with it. Don't touch it. So let's go to the transformer circuit breaker. Can you guys see the transformer circuit breaker? What you need to do with the transformer circuit breaker, guys, oops, you need to move it to the left.
Can you tell me how to get rid of that stuff? Because I can't.
Is it in your way?
I can't. Yeah, it's in the way.
Okay.
I don't have settings on my,
My
Where is it?
circuit breakers underneath that. I have the chiller and stuff on there
chiller?
apparently.
Let me see what UPCCs are. Let me close that one. We'll get back to it.
Must have been selected from before.
So, yeah,
Should I just redo it
UPCC,
or what?
no, you have that. Let's go back on that. No changes. Okay, so here's much over here.
Yeah.
And I think you can remove. You see remove here? Remove from care. Done. The care, the same thing. I don't care about that one, right? That's a trimmer.
Yeah.
You see where it says remove from care? Where does it go? Remove from care. Done. That's it. That's your where we are. It's set.
But I don't have settings
That's
actually.
really different.
The settings for what?
Let's see what it says, like component settings.
Yeah. You didn't load your component. Let me see.
Sure, I had everything highlighted. I had my,
Okay.
circuit.
But do you have data on them now? Let's click on them. Okay. There you go. Perfect. Great.
See, like settings are.
Go to here's the care. Oh, you have to be in the care to see the settings. Yeah. Okay. Name the care of the receptacle panel. RP. New. Now we're cooking. Just say yes. Okay. Now enlarge it here and then go to settings. That's where it goes. PCC.
Okay, that's why I went.
Yeah. Okay. And drop 200.
This, that was different.
And okay, you can. Yeah. The top is okay. We're good. Any question, guys? Any question about this one? So, let's coordinate the receptacle panel. To coordinate the receptacle panel, all what you have to do is just take the receptacle circuit breaker, move it. For now, anyway. Move it to the. This is good. It's not touching. Now look at this one. This circuit breaker, guys. This is the panel circuit breaker. It's overlapping with the transformer. Can you guys see that? Let's go to the settings. This is my 25. I can move it up or I can move it down. So let me tell you how this goes. Can you guys see the main? Is the main touching anything? No. So we're good to go. Let's go to the transformer ahead of the circuit breaker ahead of the transformer. Is it touching the transformer? No. So we're good to go. Then let's go to the transformer itself. Can you guys see the transformer curve? Can you guys see that transformer curve? Grab it all the way. The transformer curve, Spencer, this is the damage curve for the transformer. Meaning, if the circuit breaker does not trip, this transformer will burn. Okay, so let's go, and that's how we coordinate it. This is my, if you guys can see, this one is overlapping with the transformer damage curve. I care less because this panel, this one is at the secondary side of the transformer. So let's just go to this one. This one, you need to grab it and get it as close to the damage curve right here as you can. Can you guys see that? As you can. The good coordination. Oops, we don't want to. All right, there you go. There you go. So let me say one little thing, guys. This circuit breaker is ahead of the transformer. You want the circuit breaker curve to be as close to the damage curve without touching it. So that's kind of the art. So you want it to be as close to the damage curve without touching it. And of course, if we size things right, can you guys see? I don't want to move it all the way back. I want it to be as close to the damage curves without touching the damage curve. Okay? So play with that one. The settings of this circuit breaker is I put a 1000 amp. 1000 amp might be way too much for this. So I'm going to go try a 400. See? That's just almost, because the secondary 300 might be, if you guys pick a 300, might be the best way to do it. I changed the plug, the sensor. The sensor?
Sensor or the plug?
The sensor.
300?
300 and 300. There you go, 300 here, move it. So might not be, let's go to set 121. There you go. Let me just see what size transformer am I using here. I'm using a 75 transformer, guys. A 75 kVA transformer. To size it right, here's what we do in the transformer side. You take the 75 divided by 480 equal, divide by 1.73 equal, times 123 equal. I have a 90 amps on this transformer. To size it, guys, we have secondary and protection, so I can multiply by 2.5. So times 2.5 equal, I can get my circuit breaker can be as high as 225 amp. 225 amp. To size this circuit breaker right for this transformer, the settings on it should be 225 amp. Do I have a 220? Here's a 250, very close, right? 250, and I might be able to adjust this one to 0.95. Can you see that? So this is 250 times 0.95 equal. This is 237. That's as good as it gets. Maybe I can go to 0.9. So 250 times 0.9 equal. Perfect. If you guys set the settings at 0.9, the sensor at 250, this is exactly what you should have sized it based on NEC code book.
So it's going over the bottom of the line.
Now then, you need to adjust that one a little bit up.
Can't move it over if I use 250.
If you use a 250, you can't move it over. Can you get it as close as mine?
Yeah.
That's as good as it gets.
Mine's right on top of the transformer.
Yeah,
Right on
it
top
is.
of the transformer.
It won't let me drag it over.
Okay, do me a favor. Can you look at the size of the transformer that you have? Click on the transformer and go to the size. Do you see 75 size transformer?
Yeah.
Okay, good. So that's the you're using the same transformer that I'm using.
Where do you, okay, I'm on device. I see, I don't have that screen.
Click on the transform. Oops. Click on this right here, and if you go to no, you have to click on this
Yeah, I
here
got it,
first.
but-
Is it black? Turn black.
Okay, never mind, I got it.
Okay. All right, let's go to the head of the transformer. Jim,
Yeah.
is your setting? What's your setting? Does your setting look like 250 like mine? See the setting right here. Is it 0.9?
250, yeah. Mine is.
That's the mean. So this is as good as you can get between coordinating the main, the primary, the secondary, and the all transmission device for this.
A little different. It's close.
250, 250. There you go. Oh, grab that there. Yeah, you can grab any component of that. You do.
How do you, so mine will move.
I might have to lower it slightly to get, I don't want it to touch, you know. There you go. You're good. Right exactly where it should be. You guys understand?
It's overlapping and it doesn't let me move it.
So I did my little thing and I'm missing with the back.
That's circuit breaker? Yeah, you're missing that one. Yes, so when the minute that you get the info,
I tried
library,
to copy it.
library, this one we grabbed it from thermomagnetic and Cutler hammer. We went all the way to Cutler hammer and it.
I got the same. I got the weight. Great size, a great setting, and then they all look like that.
Vincent, what was the size of, click on that green transformer, the green here, and see what's the name of it? Yeah.
Well, it's a receptacle panel.
Yeah. There's right underneath, it says, you go to the device, it says, power hammer and the type.
HKD,
There you go.
100 to 400.
HKD. That's it, 100, thank you. That's the one that we want. And you're good, and we wanted to grab, this is on the secondary, so we want to. Okay, let's go back in here. This is the receptacle panel.
They're not the same.
I have a video in my car, I tried to record it, like,
Let's go to the settings for settings, let's take it to 25.
and then I did the camera.
Adjust
Oh, it
this,
sounded
okay, good
like-
here. Okay, are you guys there?
No, mine looks goofy and I can't
You're
move it.
going to the lighting, huh? You're not? What's your situation?
I have the settings you have, but,
Okay.
and I can't move it either.
let's see. Okay, this is 1,000. So we need to go take one to, let me see if we can go to this one. Yeah, this circuit breaker is not the right circuit breaker, that's all. This one is okay. Yeah, this one is okay. This one is not the right one. So let's go to the library, device. Where's my library here? This is the library here, the library. TKT. And so again, what was that? HKD. HKD 100 to 400. That's it. That's the one that we want.
Mine doesn't do it. Yeah, I think you have to hit a try. Mine doesn't.
Oh, it did it. Good, here we go. So perfect. You're right on the money. Let's go to 225. That's the receptacle panel. So 225, 240, 225, 240. There's one 225, isn't it? There we go, 225, not this. There's one 225. 225, we're good. There we go. Here's your curve. So here's your main. Here's the circuit breaker. Here's the protection of the switch gear. Here's the panel. And as far as you want this to be as far as you can get it. Settings. Okay, you're good. Okay.
Hey, Chad,
Yes.
I got an extra line to that extra line. My switch gear, I don't know why it's. This line right here.
Oh, that's a cable. Grab the cable. That's easy.
You just take that out.
Okay, any question guys about this? Any question? Let's go ahead, Holly, and run. Let's go ahead and run a report. Camille, my friend, let's go ahead and run a report. Run. We're gonna go run TCC report. The name of the TCC we're gonna run, guys, is RP. Okay, take the default and save it. Now here's the settings that you're gonna be giving to your electrician to go and set all these circuit breakers, guys, in this area.
How do you run the report again?
Let's go close that one more time. Are you guys there? Go run. All the way to the bottom, it says database. Well, it doesn't. I already ran mine. You should see a TCC report. Did you guys have a TCC report? These reports, guys, every time you do change one of them, you have to rerun the report. There you go. I touched it. Every time you touch something, you have to run the report. It's not like Revit where it's a database, and if you change one thing, it updates the database. The reports, every time you change something, you have to rerun your report. Did you guys hear me? Just the reports. Everything else will be loaded. Okay? Now exit from there, and let's go do one more, and then we'll let you go eat. Okay? Which one did we do? We do receptacle panel, lighting panel. Let's go do, guys, a mechanical panel. You guys mind if we do a mechanical panel? Click the same thing. Click on the main. Hold the control. Grab the mechanical panel to circuit breaker. Anything else I need to take in the mechanical panel too? I guess I can take. The load is usual. It's not a big of a deal. So let's take these two together only. Click on the curve. Did you guys pick them up?
Yeah.
Click on curves. Name them MP. This is MP-1. That's mechanical panel -1. Thank you. -2. New. And guess what? Here's my curves. The same thing, guys. I need to go readjust the settings. Click on 0. I double zero it here, and off it goes, and you're looking at a curve like this. So what you do for the mechanical panel, I have an 800 amp mechanical panel. All what I care about is just move it all as far as I can get to the right, as far as I can get it to the right. At this point, that's as good as you can get it. As far as I can move it to the right. Done. Here's the coordination for your mechanical between your main and your mechanical panel. Spencer, what do we need to run for it? Every time you do one, what do you need to do? Run a report. TCC, the same thing. Okay, yeah. Okay, yeah. You run a report, save it with other reports. Every report you run is saved, so you can print it and close it.
So do what once you're done, logging?
One more time. Okay, so if I go run, TCC, run a report, okay it again, and after you go, if you rerun it, it asks you if you want to replace it, yes, and here's your report that you give to your electricians to adjust. When you're done, exit out of it, and you go back to your one-line diagram. We made 3 curves, right? We make the chiller, we made the 3 or 4. Let me see how many we had. We made 3. We made the chiller, the mechanical panel, and the receptacle panel. We made 3 curves. Okay?
You want 4?
We made 3 curves. Now here's what I want you guys to do. Let me highlight that one. So we made that's it. You can do the whole coordination, guys, the same way. But before you start doing the coordination, it would be a good idea to size all your equipment as it should be sized. So let me guys ask you, tell you which curves I want you to run. Okay, hold your horses and sit back. Do me a favor. I want you guys to run one more. We ran. What did we run, Spencer? We ran. Is this the receptacle panel? Can't see. We ran the receptacle. We ran a report here. We also ran a report here. Right? These are my reports. And we also ran. Where's my mechanical panel 2? Mechanical panel 2. I ran a report between this and this graph, right? So these are the 3 reports that I ran so far, right? Can you guys see me? See the curves? I want you, my friends, to run this report. The same thing here with all this. That would be the. Would that be the bus dock 28? Run a report with bus dock 28.
All those reports?
Yeah, so this is number 1 that you guys are going to be doing. And lighting panel, we didn't do a lighting panel report, so please do me a favor and grab a report here and run it with lighting panel. So that's number 2. Lighting panel. So we're going to do lighting panel. So how many reports we're going to end up with? 5. 1, 2, 3, 4, 5. Any question, guys, about these? Now you can run report for every branch. When we do coordination, guys, when we do it for hospitals, sport arenas, we do coordination for every feeder coming over the switch gear all the way down. Be my guest if you want to do it, but that's give you the idea of how to do a coordination for a power system analysis and coordination. I will take a snapshot of this so you can, if anybody forgot what we want. All right, did you guys get them? All right. Now the last thing I want you guys to do is print reports. When you're done, the first if you guys go to the package that I gave to you, I am asking you to print the following reports from this software. If you guys look at the last page on the package, it says project binder tabs. Didn't you ask me about the tabs this morning? Do you see the project binder tabs? Everybody can see the project binder tabs? The project binder tabs, right here from the package that I gave you guys. In the project binder tabs, you need to print the following. I need you to print the one-line diagram. It's right there. short circuit report, input report, load flow report, coordination curves, and reports. So let me show you how you print the one line diagram, guys. Very easy. Project. If you go to where would I haven't done it for a while. Documents. Where's print? I need print. You can print it directly from here. Project. Export. We don't want to export it to anything. We want just to print. Edit. Print. Everybody can see here. Print. Can you guys, if you hit project, you're in the one line diagram, just go to document and print view, and it should print. It should give you the one line diagram. You can set the paper. You can set your paper to 11 by 17 and so forth. You set your stuff. This is letter.
Where did you find it?
One more time. You go to documents. When you print, guys, go to documents, and you can print view, and here's what you're going to be printing at. Okay? So that's for the one line diagram. For the reports, for the curves, let's go for the curves. Any question, guys, how to print the one line diagram? Right here, documents, and either I go print view just to look at it first.
11 by 17.
11 by 17, you have to adjust your document from right here. You get page setup, you adjust your page and change it to 11 by 17. Curves. If you guys go to curves, here's the curves. Click on the curves here. Chiller. Double click on it. Here's my chiller curve. I need to print my chiller curves. So I believe if I go print, there's, how did we use to print the print? PDF somewhere. Component, capture, print view. There you go. If you go print right here, you're in here, go document and print view. Here's the curve. You can set the printer, guys, when you set it up to whatever. This is 11, this is 8.5 by 11 is perfect. So one more time, document and print. Don't go to the forms. That's really a whole different animal. Print view, and you can print this curve for me. Okay? The same thing for all the other curves, guys. All the other curves that you did, you're going to print them. The last thing you need to do for Chad is you're going to print the reports. Can you guys click here one more time? Camille? You want me to go back to the okay. Reports. You need to print multiple reports, guys. If you click right here, can you see where it says reports here? Right here. Click on this. It says text reports. Here's all the reports that you're going to be running. So if I ask you guys for the input report, click on, don't print it. Please don't print it. Double click on it. Here's your input report. There's a lot of pages in it. So if you come over here and print preview, don't print. You should be able to, where's the next page? You should be able to get all these pages and hit print and you print them. Close it. Let's go print another report. Print, text. I need, for example, Spencer, I need the report for the RP report, the coordination. Double click on this. All these you guys have random. So click here, and again, here's the printer, as a matter of fact, right here. So if you click on the print view, and here's your report, 2 pages, 1 page, next page, here's 2 pages report. If all your reports will be in one location, guys, if you click here, you're going to find all your reports that you need to print. All of them are here. Let's go to the short circuit report. Chiller, RP report. I ran input report. I didn't run short circuit for here, but if you have a short circuit, let me just go run short circuit on mine. Run the short circuit like we did last week. Great. Go to the report. Click on it. So now you have short circuit right here. Short circuit report, it was there. Here's a short circuit report, guys. If you go print view right here, I think this is a big, how many pages? I can't remember how many pages that would be. It's a lot of pages. 27 pages. 20, what is it, 27? 32? Going previous. Okay, 32 pages. That's all right. Okay, like everything else, guys, this software is garbage in, garbage out. If you don't put the right data on it, you don't get the right answers. But using is really piece of cake. Putting the cables in it, running the short circuit, running the load flow, and the coordination, piece of cake. Any question? Any question, guys?
If you wanna put that, or print that?
Yep.
Can you preview it and there's nothing there? Or do you still?
Preview. Maybe it's next or previous. Did you do next or previous page? Close it. Let me see.
Change it to 11/17. It's just not, it's not happening. Can we make it?
Okay, you change it to 11/17, document, and preview. Okay. It did.
It was there.
Document, creates a, 11/17, that's, okay. Interesting.
Don't worry about there.
But it printed was 11/17. It didn't have 11. Okay, let's just see one thing. Let's go change this one to 11/17. We can have 11. There's 8
As far as I'll get
and this is okay now. Okay. Okay, let's get out of one view and go quickly. All these updates are in there, not wrong in here. Just trying to see if it's text. Import and preview. Not sure there. See it here?
Well,
No, this is one. This is good. Okay, perfect. Just want to see if it's okay.
Oh, well, that multi things.
Yeah.
Everybody who rides that, I swear, smokes that every day.
Probably.
And then rides them mountain bike.
Close it and open it, see if that does it.
Yeah. We should be able to do it. And there's other options, you can export it to CAD and print from CAD, there's multiple options for that.
Any question, guys, about coordination? Any question about the coordination? So we did the short circuit, we did the load flow, guys, last week. Today we did the coordination, over competition coordination. We printed the curves. Like Chanel, you said, my friend, you're not an expert in PTW, but you should be able to run these stuff if you followed up with us. This is videotaped. It will be on YouTube soon.
I understand. It seems like a very in-depth program.
If you want to, yes. There's Mishad Kuli has only one guy that does all these analysis. So when you go into the depth, but that will give you another dimension for your career, another dimension.
Said everything, just a little over my head with some of the stuff that we're doing, like full curve. I mean, I can adjust it. Just don't understand everything that's going on with it.
One thing understand, they don't have to overlap. To do a good coordination, the curves don't have to overlap. See, look like this. Why? Because if they're overlapping, means the settings are low, both of them are set low, and you don't know why the whole coordination is. Everybody knows why we coordinate, guys. If you have a short circuit in the chiller, what do you want to trip? I have a chiller here. If I have a short circuit right here, a short circuit right in the chiller, which circuit breaker do you want to trip?
The one before all.
The one, yeah, absolutely. So the short circuit happened here. It keeps going up, 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 up. It hits first. Which curve it hits first? It will hit the circuit breaker that protects the chiller. That's what coordination is. Now, if I grab this curve, I'm not, but if I grab it and bring it like this, if I grab this curve, the red curve, and bring it like this, guys, then it's going to hit the main before it hits the circuit breaker ahead of the chiller, meaning your 4,000 amp switch you will trip instead of the 1,000 amp circuit breaker for the chiller. That's what the coordination is all about. Any question, guys? Any question about that? Okay, that's all what I have. So go eat